The 68, 95, 99.7 rule is a rule that's sometimes used if you don't have a calculator or a chart or anything like that available and you just want to roughly estimate. It's a very rough estimation in general, but you can actually do quite a bit with just knowing those numbers. What these numbers represent is if we have our normal distribution, then within one standard deviation, you have a total area of 0.68. Within 2 standard deviations, you have a total area of 0.97. And within 3 standard deviations, you end up having your total area is 0.997. So you can, or this one should have been 97. This should have been 95. So you can use this, especially in combination with the fact that you know that everything is symmetric. You could, for instance, say, okay, well that means I could actually find this area right here. I know that the area that's within 1 standard deviation of the mean is 0.68, and this is exactly half of that, so that means this area must be 0.34, and similarly there. And that means I could actually figure out what is this area and that area. Well, I know 68% is already accounted for of the 95% that's between here and here, so let's figure out what's been accounted, what's left over. Well, 0.95 minus 0.68, there's 27% of the total of the area left. That's split evenly between those because it's symmetric. So that means each of those must be 13.5%, 0.135. 0.135. And similarly, you could figure out what the area in those parts are. This is 0.997 minus 0.95 because 95% of the area is accounted for. That's 0.47 split between the two of them. Divide that by 2. This would be 0.0235. 0.0235. And then I could also figure out what the area on those tails, what the total area on those tails is. I know 0.997 is the total area between, that's within 3 standard deviations from the mean. So using the complement rule, 1 minus 0.997 gives me the area on the outside. So split between those two tails, I must have a total area of 0.003. Divide that by 2. I could get an area of 0.0015 on each of them. This is, I think, kind of useful for you to get a little bit, this rule, even if you're not going to be using it, it gives you a good way to estimate how much area you should have. If you're talking about the normal distribution, how quickly you should be encountering the values. You can see if you're going 2 standard deviations away from the mean, you have 95% of the values already. If you're going 3 standard deviations away from the mean, that means you have 0.997. That means if you had 1,000 values, only 3 of them would be outside of the 3 standard deviations on the average. If you had only 20 values, only 1 of them would be outside of 2 standard deviations away from the mean, since that's 95%. So it's good to give you a little bit of an intuitive feel for how tightly this distribution is, how tight the distribution is.